Hello everyone. What we're going to do is we're going to make an electromagnet. Okay? Very easy. All you have to do is run a wire around something that conducts magnetic fields very well. So I've just chosen a huge, a huge iron nail. Okay? What you have to do is just this. Just keep winding it. There's no tricks about it. I mean, I could do better and wind it more tightly. The tighter you wind it, the stronger your electromagnet will be, because you're concentrating the current in a smaller area, and that's the goal of winding it. See, when you wind this really long wire, which will take me a long time to do, as you wind it, what you're doing is, as current passes through this, you're forcing the current to go around and around this iron nail, which conducts magnetic flux very well, and you're forcing it to go around this iron nail many times. And by doing that, you produce a concentrated magnetic field, which should be strong enough to pick things up. Alright, so what we have here is an electromagnet. Done! Let's test it now. What we have here is some iron filings. We're going to pick these up. Now, to demonstrate that this is not magical, look, it's not picking up. Oh, it's slightly magnetic. Okay, it's picking up a few because of residual magnetism. But when we turn it on, when I push current through this loop, I guarantee you it will be a much stronger electromagnet. Okay, so let's connect it to our power supply. Let's put the voltage back to 0 to start with. It's connected now. Now 0 volts. Let's push some volts through it. All right, 3 amps, 1 volt. This is I have here a 3 watt electromagnet. Look at that. Oh, it's a bad connection here. Oh, there you go. See, it's picking the whole thing up. And as soon as I disconnect it, it drops. So far I've made an electromagnet. What I'm going to do next is map out the field lines. Okay. So here's a piece of paper, here's some iron filings, and this will get messy, but no matter, I'll clean it up. Connect it up so the field is now active. If I sprinkle some iron filings on it, you see the field lines slightly get mapped out. You see that? Here's one pole and here's the other pole, and you see that the field lines sort of go like this, just like a bar magnet. Add a bit more. If you add too much, it actually becomes harder to see. That's as best as I can get it. Next we have a bar magnet. Right, blue is south, red is north, as per convention. So I'm going to put the north facing the camera. Put the sheet over it, and let's sprinkle some iron filings on it. Have a nice visible pattern. So just like before, a very similar pattern comes out from one pole and it goes back in. One pole and back in. You have this magnetic field lines mapped out. Now what I have here is 2 magnets. I'm going to do 2 mappings, one with same poles pushing away from each other, and then you should see the field lines spreading out in the middle, and another one switch, so you should see the field lines connect. So let's do the repulsion one first. I'm going to put them as close as possible to each other without them actually moving each other. I'm going to put my piece of paper over it, and then I'm going to start sprinkling a magic magnet dust. So here you see in the middle, the middle section where the fields are the same fields as north-north, the magnets are actually trying to push away from each other, and the reason is because the field lines are being squashed against each other, and they naturally want to spread out as much as they possibly can. So the field lines, you can see from the mapping, the field lines are actually being pushed away from each other. They're not joining each other. You can see the region in the middle is sort of like It's an area that's sort of low density field lines. That's why there's not many filings attached to this middle area. It's sort of drawn away from the individual magnets. So the field lines are being pushed and squashed away from each other. They're not merging. Okay? Because remember, field lines never cross, and this is the consequence of moving north-north or south-south. South-south should look exactly the same. So next part is we're going to do north-facing south. Alright, so I'm going to move as close, not too close. Alright, that's as close as I can get it without them actually moving each other. Put my paper over it, in the middle, and then start sprinkling. By the way, when you're actually doing this at school, you're supposed to draw diagrams. You're supposed to actually draw diagrams of the field lines that you see. This one's much better looking. Alright, so you see that the region in between the north-south, the field lines are very concentrated. You see that in the region in between, the filings are sort of all aligned head to tail, sort of, because the field lines along north to south, they connect with each other, and it just directly goes from one pole to the other, and it spreads out a bit here, and then it goes back into the north-south. So north always goes into south, and then you see the individual magnets, and in between the region, the field lines are very dense.